Hi, this is Mrs. Nelson. We're looking at Unit 8, Lesson 17, using box plots. The objective says I can use ranges, medians, and IQRs to compare groups. Remember, IQR stands for interquartile range. It's a measure of spread, and so is range. Here are box plots that summarize the heights of 20 professional male athletes in basketball, football, hockey, and baseball. Before we get started into the questions, I just want to label a few of the parts. So we know that vertical line segment that's furthest to the left is the minimum for the data. That's the shortest person. And the vertical line segment furthest to the right is the maximum. That's the tallest person in this data set. And then we've got our median in the middle, and that represents the 50th percentile. To find the range, we want to know the distance between the minimum and the maximum. So we can find that by comparing them or subtracting them. And that range tells us about the data in general. It's a measure of spread, how far apart or close together it is. We also have our interquartile range, and the interquartile range is the middle 50% of the data. This is where the data is typically most alike. And you'll notice each of those sectors, the far left, the two in the middle, and the far right, represent 25% of the data. And you'll notice that with each of these dot plots, that middle 50% of the data is much closer together than the little whiskers, is what they're called sometimes, to the left and to the right of that rectangle in the middle. And that's true for most data, that you'll find that as you collect data, you're going to have more spread on the left side, far left side, and the far right side, and then the middle is where the data is going to get closer together. So that's why we look at that interquartile range, why we look at that middle 50%, because it tells us a lot about what's typical for the data set. Letter A says, in which two sports are the players' height distributions most alike? Explain your reasoning. Well, we can look at three different things to help us determine how if the data is alike. We can start by looking at the medians. So each of these three medians are pretty close. They're about the same. They're within a few inches of each other. So we have football, hockey, and baseball so far looking alike because of the medians. We're going to narrow it down even more by looking next at the range. And if I look at the range, hockey and baseball have ranges that are pretty similar. They're not identical, but they're pretty similar. And then we can also look at the interquartile range, because that will tell us about the variability as well, is looking at that middle 50% of the data. So I have hockey, and I have that rectangle, and if I make a copy of that rectangle, or this is when you might use the tracing paper, and you make a copy of that rectangle, and you place it over the rectangle for baseball, you can see that the hockey's rectangle, or interquartile range, is slightly larger than baseball, but they're almost the same size. So looking at the medians, the ranges, and the interquartile ranges, we can see that hockey and baseball have distributions that are most alike. Letter B says, which sports show, the greatest variability in players' heights? Which sport shows least variability? Oh, I guess it should say which sport shows. So, which has the greatest variability? Well, the sport that has the greatest range is basketball, and the sport that has the smallest range is baseball. And I realize I just only answered the first part. Basketball shows the greatest variability in heights because it shows the largest range. Baseball would show the least variability because it has the shortest range, the distance between that minimum and maximum. And it also has the shortest interquartile range, that middle 50% of the data. Again, our objective says I can use ranges, medians, and IQRs to compare groups. And we did. We compared these three sports, the heights of the players in these three sports, by using the medians, the ranges, and the interquartile ranges to determine which are most alike and which have the most and least amount of variability. Thanks for watching.